Hello class and happy Friday. As you can see, we're moving on to Unit 3, which is energy and phase changes. And you already know a lot about phase changes. We know that it's talking about solid, liquid, and gases. We will just go in more detail on what's happening at an energy level and a molecule level than you've ever gone before. Before you begin, make sure you have the note sheet that goes with that, and you're filling it out as we go. It looks something like this, so make sure you have that. And we're going to be filling it out as we go through the notes. Okay, so make sure you have that out. And what's great about this video, please, you can pause where you write, play it again, rewind, and everything. So again, sorry I'm not there today. So as we get started, we're going to go through the notes here. Okay. So what is phases? Okay, and phases are called states of substances are called phases. We know those states. It's the solid, liquid, and gas, and when they coexist as physically distinct parts of a mixture, such as ice water, right? So they can be in two different phases of solid and liquid in the same thing. Okay, and when energy is added to or taken away from a system, one phase can change into another. Okay, so make sure you've written that part in the first part, in the first sentence. Make sure you've written in states of substances are called phases. Okay, so the next slide is just talking about what's happening on the molecule level. As you remember last unit, we first started to look at the particles of a solid, a liquid, and a gas. And things you need to know. We've talked about temperature, and as you go from solid to gas, temperature increases. Also motion, right? We talked about solid vibrates on a fixed point, a liquid vibrates on a moving point. That's why it has no shape, but it does have a volume. And then gases are just randomly flying everywhere, okay? And we talked about how the interactions of solid are strong and gases are weak. They just bounce off each other. So that's why you get that cohesion with solids and liquids. So make sure on temperature you're going from high to low, and make sure you're for molecular motion. You're going from you're going from low to high on temperature, and molecular motion you're going from low to high, but interaction goes from low over in gas to high in solids. So again, you're going to go from low to high for solid to gas on temperature, low to high on molecular motion, and then high to low for molecule interactions. Okay. So what are the phase changes? Some of these you know. We've talked about melting point and freezing point, right? That's the 2 points. If you're melting, you're going from solid to liquid. If you're freezing, you're going the other way, going from liquid to solid. Some new words you might not know is evaporation. I know you've probably heard about boiling and evaporation. We're going to talk later about that, and that does fall under that category. And then condensation is how we get rain. It goes from the gas state of water in our atmosphere, and then it goes up to the higher atmosphere. It condenses, which means it goes from solid gas to liquid, and that's where we get rain. Also, you know, being in Houston, it's very humid, and you have your drink with ice in it, and all of a sudden, all on the outside, it's covered in water. That's again, it's condensing. The water in the air is condensing on the side of your cup because it's cooler. It's cooling it down. And then the two really big words that you probably have not heard is sublimation and deposition. Sublimation is when you go from a solid to a gas without ever going to a liquid phase. Deposition is the opposite of that, where you go from a gas directly to a solid. I lived in Colorado for several years, and it's very dry in Colorado, very different than Houston. And when it snows, a lot of times it can happen because of that dry climate. The snow would not melt into a liquid; it would go right from solid to gas, and you would see the gas rise right off the snow as it was melting. So those are kind of new words. Make sure you understand those words and keep studying and reviewing sublimation and deposition. Also on your paper, make sure it is written down. Okay, so in this big unit is what we talk about energy. Energy is a big part of this unit. And sorry, just one moment here while I change screens. Sorry about the delay. Sorry about that. There we go. Now we're back to where we need to be. Almost. There we go. Sorry about that delay. Okay, so we're talking about energy. And energy is a big part of how you can get these phase changes, either through gaining energy or losing energy. And remember we talked about heat. Heat is energy used to cause the temperature of an object to rise. And then temperature is something new because we think temperature is measuring that heat, but it's really measuring that molecular motion, right? Kinetic meaning motion, how fast they move. Objects have a higher temperature if they're moving faster, and a lower temperature when they're not moving as fast. Okay, so make sure you have put that down. So the first answer on your paper should be B, energy is the ability to do work. The second one is A, heat. Energy is used to cause that change in temperature. And then the last one, C, for measure of average kinetic energy. So far your paper should look something like this. Okay, you should have phases at the top, the low to high, high to low, have the phase changes here, and these answer choices all right here. So make sure that's filled out. Take a moment if you haven't, or any corrections that need to be done. Okay. So heat, when we talk about heat, heat is a form of energy that flows between two samples of matter because of the difference in temperature. They like to go to what's called equilibrium, where they're both equal temperature. That's why your ice melts and doesn't melt. Of course, you get interrupted by the janitor. Sorry for that interruption. Hopefully I can get back on track here. So I apologize if it's a little disjointed. But going back to our notes. So we're talking about heat. And we know heat is the form of energy that flows between two samples of matter. The critical part about this slide is that you need to remember that heat, it goes from hot to cold. Heat flows from hot to cold. So you know when your parents tell you in the summer that you're leaving the door open and they say, you need to close the door, you're letting all the cold air out. Well, that's actually incorrect. So you can correct your parents next time. Disclaimer, you can't accuse me of you getting a beating, so don't come back to me on that. But it's actually you're letting the heat in, and that's what causes it to warm. So remember, it goes from heat, goes from hot to cold. So it goes from high energy to low energy until they reach the same temperature. As you can see the example here, you put the ice in the coffee, the hot drink, and it slowly melts as it becomes warmer. So remember, the big key here is that it goes from hot to cold, always. Another is to know what the unit for heat are. They're calories, and you recognize that hopefully by when you eat, possibly from biology class last year. Actually, what we eat in food is called a kilocal. It's 1,000 calories, but calories is a measure of heat. And what we mostly use in science is called a joule. And that's what unit you'll see. You'll either see a capital a capital J or a little c for a calorie. Okay. So make sure you have that filled out there on the thing, that it goes from hot to cold, and it goes from absorbed to released. Okay, it can be absorbed or released. Okay, so energy in the universe. One of the hardest parts is, and this will carry on to physics if you go on to take physics, is we're going to define the system. Is a specific reaction or process we're looking at. We're not really concerned about the surroundings. We're focused on what's happening. So if you look at this picture, what is the system? Well, we're not going to include the Bunsen burner, the ring stand. We're really just focusing on the ice. And what's happening in the ice is that there's a phase change going on from solid to liquid as the heat from the Bunsen burner is transferring into the ice and warming that temperature. There's an increase in temperature in the ice causing it to phase change. So part of the big deal is defining the system, knowing when we're talking about the system, we're only talking about those specific things. And then, of course, the surroundings is everything else. Therefore, the universe is defined as the system plus the surroundings. So just read carefully any questions or stuff and be specific what you're talking about. Here's a big science word. So here's probably a new vocabulary. I think you heard me probably use this word recently. It's called endothermic. So what is end? Remember we talked about this. Endo sounds like in if you break down the word. So in and thermic is of course heat, right? So it's in heat. As we break down what that word means, heat. And what it means is in an endothermic process, the system gains energy from the surroundings. Heat is transferred from the surroundings to the system. And you might have remembered when we did the baking soda and vinegar lab with the airbag, and some of you felt it and you said, wow, it's really cold. Well, that's because it's an endothermic reaction. It's actually taking energy, heat from you to absorb it. So that's an endothermic. So you kind of think of endothermic as feeling cold, but it's actually taking in heat and getting warmer. The system is. So it's a little confusing because you will feel it as cold because it's taking that energy from you. But in reality, what we're talking about, it's actually gaining energy like ice melting in a glass of water. It's cold. You feel it cold, and what happened is the ice is actually gaining energy, and that's why it's melting into a liquid. Okay, so that's just something. The temperature, the surrounding temperature, you feel that decrease. Okay, the next word is exothermic, and we've already broken down what is exo. Exo is exit, leave. And then thermic again is heat. So a little breaking down what the vocabulary word it means. So in an exothermic process, the system loses energy to the surroundings. So you're going to feel it get hot because it's energy is leaving, and you feel that sensation of heat because energy is going from that system into the surroundings. So you will feel it as hot, but it's actually losing energy. So it's actually going from, if you look at the example at the bottom, it's water vapor condenses. So that's where it's going. It's actually cooling off. So it goes from water vapor to liquid because the system is losing heat, but you will feel it as being hot. So make sure a little difference in that. We'll have some examples later on to show you what we mean by that. So just to recap what you should have so far, let me show you. You need to make sure you have hot to cold here at the bottom, absorbed or released. The system here is what we're looking at. Have the surroundings is everything else. Endothermic gains energy. Heat flows from hot to cold again. Exothermic process loses energy, and again, always hot to cold. So you should have that all the way filled up to this table. Okay. So we're talking about phase changes here. So here's the kind of, if it's an endothermic, we're talking about sublimation, vaporization, and melting. That's where you will feel it get cold, but the actual system is gaining energy. So it's going from solid to liquid and melting. It's going from liquid to gas with evaporation, and then sublimation again is solid all the way to gas form. Exothermic is where you'll feel it get hot, but it's actually going, the system is losing energy. So we have deposition from gas to solid, condensation is gas to liquid, and freezing liquid to solid. So you need to have that table listed. It goes right down the list. Make sure you just pause the video right now, write them down in the right category. Really important for this next test and understanding this endothermic and exothermic with phase changes. Okay. This kind of just helps. It's more of a just a graphic representation, what you need to put. Again, it's everything we've set up in just another graphical representation. So go ahead and pause the video now, fill that up, and let me show you, before you pause, let me show you what that looks like. So I kind of did it. Sorry, my handwriting and everything here. So you got the arrow, endo, you got the arrows, which are the phase changes, making sure which way they're going. And exo goes this way, endo goes that way. So go ahead and take the time, do it nice and neat. A lot of you are better writers and artists than I am. But make sure this will help with another graphical representation than just the words that you have up here. Okay, so pause the video now, take that time. I'll leave this up here while you pause and go ahead and fill that out. And when you're all done, go ahead and hit play again. Welcome back. Okay, so we've got this all graphical representation. We're almost done. The last thing is vaporation. Why do we call it evaporation? Not evaporation or boiling. We call it vaporization of that gas to liquid. Now it's broken up into those two categories, evaporation and boiling. Evaporation is what happens outside, right? That is the rain cycle, because you don't see water boiling outside. Evaporation, what happens on your skin when you get hot. The sweat is there to cool you off by taking heat from you, and then going from the liquid to gas state. That's evaporation, right? The sweat's not boiling on your skin. And it only happens at the surface of the water. So that's where you get large bodies like our ocean, the Gulf. That's what's coming, why we get water off the Gulf and why we're so humid in Houston. Any body, lake, river, creeks. That's how the rain cycle uses evaporation. It only happens at the surface. Boiling, though, you've seen that on the pod, right? The boiling occurs all throughout the pod, and you need a much higher temperature for boiling than you do evaporation. Boiling, water boils at 212 degrees Fahrenheit or 100 degrees Celsius, or as we just learned, 373 degrees Kelvin, if you add that 273 to 100. So a lot of higher temperature because it's the whole things. And so you get throughout, and you can see that why the bubbles is going from gas at where the pot is at the bottom and flowing through. So that's why your bubbles go from the bottom up, because the whole thing is turning from liquid to gas. Another point here that we're going to start talking about is called that atmospheric pressure. We've talked about pressure and how pressure is pushing down, and that we get clouds when it's low pressure, and rain and storms during low pressure, and high pressure because the atmosphere is pushing down. We get no rain, no clouds, and it's clear sky, and it's usually warmer. When you go to the higher altitudes, you actually will have a difference in boiling point, and we'll talk about that further on. So at this point, we are done with today's notes. We will have notes later on when I'm back. So make sure, I'm going to leave the screenshot up here right now and end it with it so you can pause it. Make sure you have all the notes filled out correctly, and I look forward to seeing you back on Wednesday. So please, thank you for doing the notes. Hopefully this wasn't too much of a pain, and please be good for the sub. And we will see you back on Wednesday. Have a great weekend.